When a company like OpenAI trains a large AI model, they use a massive data center. Thousands of specialized GPUs all in one building, connected by ultra-fast networking that can transfer hundreds of gigabits per second. Training a 70 billion parameter model this way costs tens of millions of dollars and takes weeks or months. Decentralized training does the same thing, but without the data center. Instead of one company owning all the hardware, independent participants from around the world contribute their GPUs. Each participant runs part of the training process, and the results are combined into a single model. The fundamental problem is communication speed. In a centralized data center, GPUs talk to each other over InfiniBand, which is thousands of times faster than regular internet. Distributed participants are stuck with home or office internet connections. This is why most researchers assumed large-scale decentralized training was impossible. The GPUs would spend all their time waiting for data instead of actually training. The breakthrough that changed this is called SparseLoCo. It stands for sparse-low communication. Instead of sending all model updates between participants, SparseLoCo compresses these updates by a factor of 146 times. Participants only need to send about 0.7% of the data that would normally be required. The result is 94.5% compute utilization, meaning GPUs are productive almost all the time instead of sitting idle. That is remarkably close to what you get in a centralized data center. There is also a cheating problem. In a permissionless system, how do you know someone is actually training the model correctly? Bittensor uses a verification system called Gauntlet that checks every participant's contributions. Miners who submit low-quality or fake work are detected and penalized through UMA consensus. The result, Templar on Bittensor Subnet 3 coordinated over 70 independent nodes on regular internet connections to collectively train Covenant 72B, a 72 billion parameter model that outperforms Meta's LLaMA2-70B on standard benchmarks. The weights are open source, the paper is public, anyone can verify the claims. This is the achievement that NVIDIA CEO Jensen Huang called quite a remarkable technical feat on the All In podcast. Decentralized training is still behind the frontier, but 18 months ago, it could barely handle a 6 billion parameter model. Now it has produced a competitive 72 billion. The trajectory is what matters.